In this video, we're going to talk about some important stats vocabulary. We have the words population, sample, parameter, and statistic. So a population is a group that has something in common, and it often refers to a group of people. A sample is a smaller group of members of a population selected to represent the population. In order to use statistics to learn things about the population, the sample must be random. And then the parameter would be a characteristic of a population, that larger group. And a statistic is a characteristic of the smaller group we've chosen, called the sample. So let's think of a situation where we want to gather some information. Excuse me. A smaller or a familiar example would be if we wanted to gather up and figure out the average height of all the students at Mooresville High School. Then our population would be all students at Mooresville High School. That is a group of people that has something in common, and it would be all of them. So a sample would be that if we realize that we can't go to every single student and measure how tall they are, because that would be really challenging, and we decide we're going to gather a sample, we need to think of gathering it randomly. So we could take every class and we could list them on paper, look at a list that they've already got up in the office somewhere. We could put all of them into a hat and we could draw out a certain number of them. Let's say we decide we're going to draw out 30 classes. We go to all those classes, but we have randomly selected them. That is super important. If you just choose that you want to go down the main hall and just ask those classes, then the information that you gather is useless because it wasn't randomized. So it must be a randomly sampled, that is a very, very, very important word, group of Mooresville High School students. Because we're doing this, because it's very unlikely that we could go and measure all the students. Some are absent, some withdraw, some add, like we get new students every day, we lose students every day. It is very difficult to get every single student correctly measured. And then the parameter would be the average height. If we could measure every single student, that would be the parameter. So that would be the true average height of Mooresville High School students. That would be if that's possible, which it's not. So, very unlikely. Parameter is kind of an untouchable thing that we never really find. We just talk about. And then a statistic is something we can find. We can find the average height of our sample. So notice those sound the same. Average height, but this is the average height we can actually work with. So the average height of our, and I'm going to put random again because it's so important, of our random sample of students. So let's summarize. So what we say is a statistic, the average height of our random sample, helps us to make estimates about the parameter, which would be if we could have measured every single student and found the true exact average height, which we can't. So we use our statistic to make inferences about the parameter to figure out information about our population, which is all students at Mooresville High School. So these four words work together to figure out information you're looking for. All right, so let's look at some examples. Example 1 says a Pew Research Center poll asked 1,102 12 to 17-year-olds in the United States if they have a cell phone. Of the respondents, 71% said yes. So the investigative question would be, what percent? Because they gave us percent, we're looking for percent. What percent of 12 to 17-year-olds in the U.S., that's important since they told us that, that's important description, have a cell phone? All right. What percent of 12 to 17-year-olds in the U.S. have a cell phone is what we're trying to figure out. So the population would be all 12 to 17-year-olds in the U.S., that very large group of people we're looking for information about. The sample is the 1,102 of them that you actually asked the question. And then the parameter is that untangible thing that we can't really find, but it would be if we could have asked every single 12 to 17-year-old in the US if they have a cell phone, we would have found the what we call the true percent of 12 to 17-year-olds in the US who have a cell phone. So it'd be the exact number, if that were possible, which it is not. And the statistic is what we actually found, which was the 71% said yes. And that was 71% of our sample said yes. So out of our randomly gathered sample, if 71% said yes, we could infer that that would be likely to be close to the parameter amount. The population would mirror our sample if we've done a good job gathering the sample. Example 2 says the average weight of every sixth person entering the mall within a 3-hour period was 146 pounds. So the investigative question, always go with kind of what they say right there. Average weight, they gave you. So we would say, what is the average weight? Of the people at the mall is what they are trying to figure out. The population would be everyone at the mall. So everyone at the mall. And if you think about that population, that's very difficult to measure because people are coming and going all the time. And then the sample would be, they didn't really give us a number of them, so we'll just say it's every sixth person that entered within the 3-hour period. But we don't know how many that was, but that was what they told us. The parameter would be if we could have actually weighed every single person at the entire mall, it would have been the true average weight of everyone at the mall. And then last but not least, the statistic, the thing we can actually measure, was that they found 146 pounds is the average weight. Okay, and that was of our sample, but that helps us make inferences about the population. Example 3 says a polling organization contacts 1,494 teenagers who are 13 to 17 years of age and live in the United States and asks whether or not they had attended a concert this past year. What is the population of the study? So the population would be, let's see, in our problem they said teenagers who are 13 to 17 and live in the United States. So we need all of those things. So that looks like B. We do not need A because it does not include the United States. And then C, they do not have to have attended a concert. That's what we're going to be asking them. So that's not needed for the population. And then the same thing for D. They do not need to have attended a concert. What is the sample of the study? So the sample would go with the organization contacted 1,494 teenagers. And then they would need to meet the same criteria as this one. So 13 to 17 and live in the U.S. So A says 1,494 teenagers who are 13 to 17 and have attended a concert. Still don't need that. Teenagers who are 13 to 17, but we need the 1,494. So B would be out. C says the 1,494 teenagers who are 13 to 17 years of age and live in the U.S. Perfect. That's the one we need. And the last example, it says, which is an appropriate description of a parameter of the study? So this says option is the true mean number of teenagers aged 13 to 17 that live in the United States that have attended a concert, or the true percentage of teenagers aged 13 to 17 that live in the United States and have attended a concert. So we could find out either one, actually. The true mean number of teenagers we could find, because we could find the mean, and then we could also find the true percentage of teenagers 13 to 17 that have attended a concert. So either one is actually appropriate. I would say that percentage would sound a little better, because we're going to calculate how many of these teenagers attended a concert out of the total. So I would say, I changed my mind. Let's take away A. To find the mean number, we'd have to have the total number of teenagers to divide by, and that would be really difficult to gather. But we could definitely find the true percentage of teenagers that live in the United States. So I believe we'll go with B. All right. So that's it for